G'day Bifrosters. Welcome to the expanded FMX universe. These are a series of 3 videos which go into more depth and leave more stuff in from the FMX presentation. We're doing this because I had to edit the FMX presentation fairly severely to get it to fit into the time limit. So this is a much deeper dive which explains a lot more. This is part 1, and this one goes through all of the setup, the scattering, getting all your points ready to start, getting everything down before you can start doing complicated stuff. And I'll stop talking and let you get on with it. Cheers. The main thing we have to do to get this effect is scatter. So I'm going to spend some time now scattering all the points we need. The ground, the house, the tree. After that, we'll be building the grass itself and instancing it. Then we'll be building the infection solver. I'm going to speed up when I do the work and explain it before and after. If you need to pause and see what the graph is doing, feel free. It's in fact probably the best way to do it. So let's get scattering. The very first thing I'm going to need to do is a little bit of set work, and what that involves is grabbing the last frame of that camera. So this is the approved camera we've got from Environments or Layout or whoever we've got it from. And you see it's got 2 keyframes on it at 25 and 175. I need the position at 175. Easiest way to do that is duplicate it. We'll rename it real quick. And then we're going to get that into Bifrost. The reason I do this is because I want to optimize all of my scatters based on my camera position. This means that Bifrost is dealing with less points without sacrificing any of the look. So how do we get a camera into Bifrost? That involves having a Bifrost graph to start with, so let's create a new graph. I'm going to name this graph. This is the first of several graphs we're going to build, and then we're going to tie them together. So we're going to import one into another. And the reason we do that is that if you've built a graph and you import it into another one, well, it becomes calculated and then it won't calculate again. And that's what we want because our scatter points will all be still. To start with, there's no moving scatter points. So I need to get this camera position into Bifrost, and I can't just drag it in. It doesn't work. Okay, so what I need to do is a little bit of work both in Bifrost and the node editor. I need an input to take the camera's world matrix basically, so that I can get its scale, rotation and translation, any other information that I want. So I'm going to make a value, and I'm going to make that value a matrix 4x4. I'm then going to connect the value to the input, and then I can delete the value. So now I have an input into my Bifrost graph of a 4x4 matrix. Nothing's connected to it yet. It's not got any information, so let's do that now. We do that in the node editor. And we get our Bifrost shape, open that out. Our camera transform, open that out. Let's very quickly name this input so we know what we're looking at. In the node editor, we now have a cam matrix input into our Bifrost graph, and we have our world matrix output from our camera connected to. We're done. We no longer need the node editor. This is now carrying the information of this camera into Bifrost for us. Let's scatter the points that we need to scatter. I'm going to first scatter on the ground. So let's get the ground into Bifrost and scatter our points on it. And I've very quickly made a display compound so that we can see what we're doing as we go. I need many more points than that. And I need those points to be thicker in the middle and stop before they hit the edge. To do that, I'm going to adjust the density weights of the scatter. Now we have more points in the center and less points heading out. I need to edit this. And that's the start of our scatter. Let's make that into its own compound. Now I need to remove parts of that scatter so that the house and the tree aren't being scattered inside. You can see here that there are points inside the house, and there are many, many points inside the tree. Before we do that, let's adjust for the camera. So what I need to do is I need to get all of the points in this shape and their distances from the camera, which is why I brought in the camera matrix. And this is going to be our next tool. So first thing I need to do is get the point position from here and convert this into a scale, rotate, and transform node. Then it's the same as we did inside of here. And convert that from whatever lengths they are to between 0 and 1. I can use this to multiply the scatter values I've already created to keep this edge all the way around, but achieve some sort of distance from camera. It's worked, but it's the wrong way around, so I just need to change this. Now you can see that there are more points here than there are back here. And if I was to check that point count, there are 46,000 points when we scattered 100,000. I'm going to need a little more density than that, so let's go to 150,000. Now we have 70,000 points on the ground, which is fine. That's a good number. If we look in our shot, go to the beginning, you can see that this is how close you get. This is the closest you ever get, and as you pull out, the grass and plants in the front will hide the grass and plants in the back, and the density will look fine. It's just a way of keeping things fast and keeping things easy to deal with. Let's make a couple of tools here. All of this stuff is our distance to camera. So let's make a compound. And we can use this over and over and over again. These two can become their own little tool here, which is just set normal range. Normal because it's between 0 and 1. And let's really, really quickly go in here. Cool. So we have our main points in, we have our distance to camera. We need to cut some of these objects out of those points. We don't want any points inside of those objects. The way I'm going to do that is with a raycast system. So let's do the tree first, and we should just be able to use the same system over and over again. First thing I need to do is bring the object in. And now what I'm going to do is I'm going to do a raycast from the points on this object to the points on the ground. I'm going to use the position array to build a direction array. And that direction array is pointing straight down, 0, -1, 0. I'm going to put in a location scope so we can see what we're doing. And attach that to a terminal. You can see what's going on here is that it is projecting from every point on the tree down, straight down until it hits the ground. These dark blue points means that there is no hit there. I don't want it to find any points projected from here, just from this one. So what I can do, in my raycast locations, I can change my cutoff distance to 2. That's probably a little bit high because this branch is destroying points as well. So let's take it back to 1.5. So this is finding these points on the ground plane that shouldn't have points in them. The way we stop them having points in them is we sample those points and find anything within a radius. So let's go ahead and do that quickly. We're going to sample the point position, and we're going to sample the point position from closest. So we get the points on this object rather than the interpolated positions. Then we'll use that to get points in radius. And the get points in radius will give us the point indices on this object that are being sampled from the raycast. Once we have the point indices, I can take our density array that we're building for the scattering. I can set values in that array based on those indices. it's cleared out all of the points within a radius of 1 of these sample locations. So now I can take my points in radius and I can change the radius. Now I need to be careful here because what I'm looking for is an infection later on that will run through these points and then be caught by these ones, etc., etc., etc. So I need to leave it pretty close, but not inside, and we've achieved that here. Could possibly change our max distance to 1 again, which will give us a few inside there. So now I'm going to very quickly make a new compound here. And I'm going to call that no points down. I'll do some quick renaming. And this is now doing our culling of points based on a downward projection of the trunk. If I turn off the display flag, it's going to hide the location scope, but I'll leave it there in case we want to look at it later to make adjustments. The nice thing about building this is that I can now just go ahead and plug it straight into the house. There will be some adjustments needed in radius, but let's just plug it in and see what happens. I'm going to need to decide what I'm going to bring in from my house. And the easiest thing to bring in from the house is the chimney, the roof tiles, and the step. Because if you project all of those down, they cover the rest of the house. Now we need another no points down. And we need to plug in our merge geometry. What we also need to do is set the output of this in the array as well. The easiest way to do that is to build a new array and add these to it. And we can see that it hasn't quite worked. And the reason for that is, in my no points down, it's based on two things. It's based on a raycast and a points in radius. The raycast has a cutoff distance. If I turn that cutoff distance off, you can see that the roof tiles are now projecting straight down and killing those points. Let's have a look at the projection. There it is. This gives us just a little bit of a problem. If I turn this off, you can see that I might get an infection catching here, but I'm not going to be infecting the step, and everything else is far too far away. Let's make life a little easier on ourselves now, and I'm going to output some settings from this into our input so that we can change them from outside. And you can see what this does. So with some judicial adjustment to the radius and the cutoff distance for the projection, I can get something that at least the chimney will catch. But to get things closer to these walls, what I'm going to need to do is scale down this roof in place. So let's do that. So now you can see that it's getting the point position, multiplying it by a number, and setting it again. What this number is the scale of this. So what I want to do is I just want to shrink it just so that it's touching on the sides. And what this is actually doing is scaling these roof tiles in place, which of course then will be changing the projection. I might want to just scale the X and Z rather than the Y as well. So let's grab this and change it to a vector 3. Make sure this is set to 1, 1, and 1. This way we can set our X and Z at the same time, look at what our projection is doing, and get something that's reasonably close. So now I'm reasonably confident that I'll get infections catching on the back wall, the side wall, and I can also add an offset to my roof because we're never going to see or render this. So I can just add that there. We'll take that down to 0. Now if I want to, I can offset along the Z direction just a bit negatively. It just pulls these in, pulls them in here. So I can get a good contact with the wall. And with that, we're pretty much done. Maybe give it a little X offset as well, just to get what we need. And we can of course edit this later, but for now this is a really good starting point. We're done with this. Let's turn this into its own tool. And that's our base scatter completed. Moving on to the house and the tree. So let's get our pot back just so we can see what's going on. It looks a bit nicer that way. And our tree can come back as well. Get our trunk back, our branches and our needles like this. Let's scatter on the house first. So for the house, again, we're going to choose what we wish to scatter on. And if you saw the renders, it's not scattering on the door or the light. It's also not scattering on these bricks because once the crystals start to grow out, they cover the bricks anyway. I decided it wasn't really needed. And this is where we only want to scatter things where we're actually going to use them or see them, which means by going to our shot cam end, we don't need any scattering on the back of the house at all. Let's get on to scattering from the house, but only scatter where we need to, and I'll show you how as we go. So first off, let's choose what we need to scatter on. We need to scatter on the roof tiles, the walls, the edges of the door and the windows, and this little planter box here. So this is pretty much what we're going to be wanting, except this, maybe we want this border here, and of course that plant pot, which is there, shutter, which is there, that's a good one to have, and we definitely want to be scattering on that as well, the windows. So there we are, that's pretty good. Let's bring those in as an array. So it comes in with input by path, and it contains all of these objects as an array. And we're going to be using this to scatter on the house. Now we're going to use a very similar system to here. This is our main scatter. So this is the scatter that we're going to instance plants on. Whereas this is going to be our house scatter, which is we're going to instance on the house. The difference is the house grows crystals, the base grows plants, which then grow crystals. The base grows the tree, which also grows crystals, and so on and so on and so on. So we've got a primary and a secondary, and in a couple of cases a tertiary scatter going on here. First of all, let's get some points on the house. Here are the points we have scattered on the house. There are 100,000 of them. We want to do both the density we did before and the new direction to camera. So you can see there is more density here than there is here, along the line with the camera. So the way that we're going to remove any point that isn't seen by camera is we're going to raycast those points in the direction of the camera back onto themselves and see what they hit. Let me set that up and I'll go through it afterwards. Now you can see our location scope with all of the arrows pointing towards the camera. What we're looking for is all of the misses. So every point that is dark blue is what we want. The way to do that is to use the found port. This will report true if it's hit something and false if it doesn't. What I've done here, just so you can see, is I have taken the house geometry, I have raycast from every point position on that geometry. I've got the camera position and every point position, made vectors from them by subtracting the point position from the camera position, plugged that into my directions. So what that is basically doing is it is raycasting from every point on the object out towards the camera. I then made very, very sure I had a minimum distance. So if I turn that to 0, everything goes wild. The reason I need a minimum distance is I want to see what hits itself, but not right on the point that it's at. So I've set a minimum distance of 0.1 is probably better to get a bit more accuracy. And now what I'm getting is any point that hits itself returns a true in this port here. But what I want is the points that return false, because I know those are the ones that can see the camera. So here's how we do that very, very quickly. We're going to need to plug this into our scatter. This here is our weights array that was already set up for the density, so that the points are less dense over here than they are over here. We need to find all of the misses, so all of the false in this array. This is a Boolean array. And I want to find false, so things that don't hit. I've now got an array of indices, which are the indices on this object that are missing. The indices on this object here that are visible to the camera. So I need to reverse that, invert. I need to set all of these indices to 0 in this weights array. The only points that are being scattered on this house are the ones that are visible to the camera. Now, we are scattering 100,000 points. We are seeing 26,000 points. And that's what I mean by optimization. I know that at my shot camera, at the beginning, might not see anything there, but the crystals don't start to grow at the very beginning. And the crystals grow from the bottom up. So as I pull out, pull out, it's at this point, because we took the last frame of our camera to do all of our calculations on, that this is what the camera sees. Now, I can, and I will, up that number to 200,000. I have a lot more density. It's nice and random. I'm not going to go for blue noise or anything like that, because what I'm looking for is small gaps between these points that an infection will grow in. So I've got nice distances between my randomly scattered points. I've got some nice density. The only issue I have right now is I have a big gap here where the overhang of the roof tiles, and you can even see the pattern of the roof tiles, the overhang of the roof tiles is cutting this out. And the way I think it might be best to fix this, and this is why we're doing this modular, because I need to put another object in here in between this. And I happen to know that in the set, I have this object. And this object here is the wooden roof. So I've already done all this calculation. I really don't want to do it again. All I need to do is to make sure that this is set to fan in, so I can add new objects to that array. And I drop this in here, and you can see it just automatically takes care of it for me, including the distance to the camera, including the direction to the camera. That makes things a lot easier. And now I've got a couple of places where my infection can catch and spread to the roof. I can make some edits on that direction if I want to, but right now I'm quite happy with it. So let me just wrap that up in its own tool. Now we're going to use that for the trunk. Because we've made it, that's what it's there for. We have our camera matrix coming in. And now that we've made this into a compound, I can just plug other things into it and check how they work. So let's do this for the trunk. And there we are. That's very, very quickly set up everything we needed there. Everything the same as here. So they're denser closer to the camera. You can see it on this edge. They're also culled where the camera cannot see them. And I'm going to add one more thing as we go out of here, because the reason that each of these have their own scatter is because I need to treat them differently in terms of, I need to give them different attributes for the rendering. So whoever picks this up after me will have a different attribute for the house than they do for the tree, and are able to use that if they want to. So the one thing I'm going to do is use one of Maxime's nodes. Which is frustum culling. And I'm going to put that especially on the tree because the tree goes out of frame. And what this does, it culls everything outside the camera frustum. And don't forget that I'm using my final camera. So these are all of the points that are ever going to have to be in this shot. They don't change, they're static. Those are all of the points that I'm ever going to need in this shot. What I also need to do is get rid of any points that are inside, that are beneath this. So this is the black points of the ground. Any points beneath the ground I don't need to see, and I definitely do not need to calculate on. So I'm just going to very quickly do a no points down, but it's going to point up. And I'm going to change this a little bit because I don't need the points in radius for my output. What I'm going to do instead is I'm again going to use this found. So when it actually hits something, I'm going to find all of the true and output that here. That means I can get rid of this. So we're adding to the weights array for the scatter on that particular object. And you can see that everything below the ground has just disappeared. It's not being scattered on because it has a density weight of 0. This is the power of the scatter, and we're going to get into even more stuff later. So at this point we have the tree, the house, the ground. It is exactly the same method to do the needles and the branches, including a frustum cull, because those objects are outside of the camera in the shot. That is the trunk, it's partly out of shot. The branches are partly out of shot. The needles are partly out of shot. And we want to do this procedurally, so I will go away and just do exactly the same as we've done here to the needles and the branches. So I'll be back real quick. Okay, so we're back, and you can see that we now have the branches included. They're denser towards the front, they're less dense towards the back, and they've been cropped by the frustum culling. And we have the needles included, which are the red ones. And something I just want to draw your attention to here, you can see what I mean by modular. So this bit here, if I put a backdrop around this, this is the needles. And this part here, if I put a backdrop around that, that is the branches, and so on and so on. This is what I mean by modular. These are modules. So this is a module that does one thing. We plug something into it, and the same thing comes out the other end, but on a different piece of geometry. And this is what the power of proceduralism gives you. I could, for example, wrap all of this up in a compound as well, including the display and the outputs and everything, and we could just copy and paste that and plug new things into it, which is essentially what we've been doing, but I just wanted to show you how it's actually built. And that's the trunk. And what I like to do is, if I've chosen a display color, I like to make my backdrops at least related to that display color. I mean, if I make that bright yellow, you're not really going to be able to read anything in it. So what I sort of like to do is make it a darker version, and that's yellowish, and it's called trunk, and you know that it's the trunk because the trunk is yellow. This, of course, this is the house. This is also a module, but it's done a little bit differently. So I could do the same thing, give it a backdrop, change the colors. You can see here that this large lump of things here, these are the base scatter, these are the black ones. So it's up to you if you want to add backdrops to remind yourself what you're doing and where things are going and things. At this point in time, I'm just going to do it for the tree. So let's do it for the house. Why not? It doesn't take long. So we've now finished with the scatter. We've scattered every point we're going to use apart from the points on the grass itself, which is a secondary thing. It's time to make an output for this and get it ready to go into another graph. We already have an output. As far as I know, we can only output one. So we can have one output to go in. Even if that's not true, even if you can have multiple outputs, I actually think you can. I prefer to do this as one because it allows me to put the rendering attributes that I want to put on it. So what's the house, what's the tree, what's the branches, what's the needles, what's the ground here, and have it just carry through all the way to the end until it's given away to be rendered. So the way I'm going to do that, I'm going to add a property to every output. And that property is going to be an integer, and it's going to be the name of where this is from. So let's do that. Great, that's all done. So all that's left now is to merge all 5 of those and put them into the output. And then I will show you, once we get it into a new graph, how to split them up. So there we are. We now have one output containing 5 sets of points that have become one set of points. They're carrying their colors with them, and I've still got the display flags on. So that is this part completed. We have now scattered every point we need to scatter for this project. Let's go on to building the grass. Okay, so here's how it works getting it back in. You can see here I've just got the house points, but I am bringing in all of the points. So let me quickly put this back together for you, and you guys can see how it works as well. Delete that, we'll delete this. I will make a new graph. Let's name that. And then we just drag our scatter across. Here's our scatter shape, and I'm going to put this into a compound. I'm going to list all of our properties that we want to be getting, so house, ground, etc., branches and trees, in a string out here that will be turned into an array for me with the string to array node. Then that array goes into our new compound, and what we need to do inside of here is we need to search these points for this attribute. Now, the reason I put it in an array is because you could do this in a loop. So we could loop through this, but then the problem we have with that is outputs. That means that we would end up with an array of this, and I want singular outputs. So let's just do this as modules one by one, and then we'll be getting into loops a bit later anyway. And there you go. This has just got the ground points out of the points that we brought in, and it's done it by taking the first in the array. If we check to see what the first in the array actually is, you can see it's ground. So how this works is it brings in the points and the array. It gets one of the array values. In this case, it's the first one, so value 0. It gets the geo property of that name, and we know that these are int arrays, so we've just set that to array int. Gets that data, checks to see what's equal to 1. Finds all true in the result of that, because these have all got the ground attribute on them, but some of them have a value of 1, these ones, and some of them have a value of 0. I'm then getting the point positions from the big merged array, and then getting only those point positions from that array that have the ground attribute on them, making a new set of clean points, so these will have nothing on them but their position, so it makes things very quick and clean, not even a color, and then outputting that for a display, and then outputting that to the output. Let's just name that. So now we have one, it's a module. Let's make this into a compound so that we can do this very quickly. The only thing we'll need to be careful of here is we need to output a couple of things so that we can control them from outside of the compound. The first one is get from array here, because this is what gets from the string array, and then I think we're good. We are good. So now all I need to do, let's clean this up a little quickly, copy and paste that, change index to 1, let's put it up into the terminal to make sure we're not going mad and haven't made a mistake. There's the house, that's awesome, that goes out there. And just as before, let's go through and do all of them. So very quickly, we've gotten what we did in our other graph over here back out to a new graph, and we're ready to start instancing. Just one note, if you need to change something, so treat this as if it's cached now. If you need to change something, say for example, I'm looking at the needles right now. Maybe I want to have a few more needles. Let's see how many needles are coming out of this. Of course, I'll need to show it so that Bifrost calculates. About 5,621. So, for example, I want to maybe have a lot more needles. Let's go kind of crazy. That's 1,000,000 points. You can see a lot more needles now. 27,000 needles. That's a lot more like what I want. So we can check to see if this is carried over. We'll go to our new graph, which is also being calculated. Let's turn that off there and we'll just put a terminal out here. 27,684. 27,684. So what you need to do is just come back in to your other one, make sure it calculates by unhiding it or whatever it is you're doing, and then it will update in here. So now we've got everything we need to start doing our our instancing, which is the next big thing. Well, that was a pretty instructional half hour. Thanks everyone for watching. Time to go into part 2 where I'll take you through the instancing of the grass, starting to get things set up ready to instance the crystals, and just moving forward on there. Onwards to the next one. Cheers.